Hi everyone, it's going to go through how to find the electronic configuration of the D block elements. So the only D block elements we will be concerned with are the first row of them, which is in the fourth row of the periodic table, and it is scandium over to zinc. But it's important to note that whilst they are in the fourth row of the periodic table, that is the 3D sublevel from scandium to zinc. Not all of these follow the same rules as our normal elements. There are two exceptions in here. So I'll show one or two of the normal ones and then the two exceptions as well. So if we have a look at scandium, which has 21 electrons. Following the Aufbau principle, the first sublevel that we look at is the 1s. So 1s can hold a maximum of 2 electrons. So we have 1s2, 2s2, 2p6, 3s2, 3p6, and then the 4s sublevel will come before the 3d because it is lower in energy. So that is 4s2 and 3d1. So by and large, follow the same rules, just with the 4s sublevel coming first because it is lower in energy. Say if we take manganese. Manganese has 25 electrons, so that will give us 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. Since it is in the 3d sublevel, oh not 10, sorry, it's 5. Since it is in the 3d sublevel, every sublevel before that has to be full following the Aufbau principle. But our exceptions here, which are the ones that you need to be particularly aware about, are chromium, which has 24 electrons, and copper, which has 29 electrons. So let's have a look here at chromium first. So chromium has 24 electrons. It is the fourth element into the 3D sublevel. So since everything before that is full, we would start off the same as we would normally. 1s2, 2s2, 2p6, 3s2, 3p6, and here's where it gets different. If we were to follow the same rule as we normally would, we would have 4s2 and 3d4. But what actually happens is that the 3D sublevel will take one of the electrons from the 4s so that we have 4s1 and 3d5. And the reason being is that a half full or a full sublevel has extra stability with it. So if we can half fill that 3D sublevel, that will give it greater stability. The 4s sublevel is also half filled, but with having the 4s and the 3D half filled, that is more stable than having a full 4s and only a partially full 3D. The other exception is copper, which has 29 electrons in it. So we have 1s2, 2s2, 2p6, 3s2, 3p6, and again, instead of 4s2 and 3d9, the D sublevel will take one of the ones from the 4s. So we have 4s1 and 3d10, because now the 3D sublevel is full and the 4s sublevel is half full, so they both have extra stability, as opposed to a full 4s and 9/10 of a full 3D. All of the other 8 elements in that block will follow the exact same rules, like what we saw up here for scandium and for manganese. These are the only elements that we are going to look at whose electrons will not follow the standard electronic configuration.